Talking about smart working or even home working these days can be really redundant. However, the work we would like to present here is something definitely new, at the same time very smart and very home. In fact, restrictions these days have obviously impact the experimental activities of our students, but they have certainly motivated our graduate student Davide to think about building an instrument. A real atomic emission spectrometer, perfectly functional and able to quantify atomic species in a real sample using only a recovery material available at home or in a common chemistry lab. Parts, which are usually used for other uses, such as a camping burner, 2 razor blades, an old CD-ROM, according to a logic not only of economy, but also of renewable and circular technologies. So it's really a great pleasure that I present you the project of our graduate student Davide Di Stasio, but not before giving the floor to my colleague Professor Barbara Roda, who followed the assembly and the implementation of the instrument, as well as the coordination of the work, calibration and application of this instrument, amazing instrument, on a real sample. So enjoy the video.
The first preliminary phases of the project were the assembly and installation of the instrument in complete safety. Our graduate student Davide has deepened the work of the instrumental analytical chemist by improving the limit of his instrument and refining the analytical method used. Instrumental analytical chemistry in this sense is a subject that increases the transversal knowledge of students by broadening horizon toward other apparently distant disciplines. Activity like this helps students improve their practical, manual and critical skills. The construction of an instrument awares students of the mechanism, strategy and theory behind complex equipment. Enjoy the video.
Atomic emission spectroscopy is one of the oldest instrumental analytical techniques and still plays a crucial role due to its high sensitivity and the ability to perform simultaneous multi-element analysis of complex samples. And AES is based on the transfer of energy from an external heat source to excited ground state atoms. The atoms returning on ground state cause an emission of discrete light characteristic of the element and with an intensity proportional to the concentration of analyte. The device is made entirely of recycled materials and uses equipment that can be easily found in normal chemistry lab. The instrument is made of nebulizer, atomizer, spectroscope, and detector. A nebulizer is formed by 2 perpendicular needles, one connected to compressed air and the other to the sample. The sample will be aspirated according to the Venturi effect, and the compressed air jet will finally nebulize the liquid. Atomizer, you can use a Bunsen burner or capping burner by placing the nebulizer outlet at the air inlet. The spectroscope is made of cardboard box with a diffraction grating at 30 degrees with respect to the entry ray, and a mobile slit made from 2 razor blades and cardboard. The detector is the camera of a mobile phone in manual mode. The experiment consists in quantification of sodium in bottled water. And for the experiment, we need standard solutions of sodium chloride, medical water, compressed air at 0.8 bar and the instrument. We ignite the propane flame. Open the compressed air and immerse the nebulizer in the solution to be analyzed. The flame will change color, indicating the type of metal contained in the sample. In our case, the sodium is yellow. The slit is adjusted and the spectrometer is aligned with the flame. We repeat the procedure for all the solutions to analyze. We use the mobile phone to capture the spectra.
Once the spectra of all the standards and the samples have been recorded, the images are analyzed using tracker software, obtaining the maximum intensity for the specific sodium emission line. Once the intensity of the peaks are obtained using profile line tools, they are interpolated in a spreadsheet with the concentration value of the standards, and the regression line is used to determine the sodium concentration in the sample.